Hello students, welcome to the e-learning platform presented by Mechanical Engineering Department of Dr. Bapuji Saroke Institute of Engineering and Technology, Kolhapur. Learning objectives for today's session are: number 1, study of lightning system. Lightning system will be studied in today's session. Second, study of types of gauges and types of sensors. This shall be this is the last session for chapter number 5, automobile electrical and electronic systems. Starting with very first, lightning system. The lightning system of automobile consists of lightning and signaling devices mounted or integrated at the front, rear, side, and in some cases at the top of an automobile. The function of lightning system are to provide illumination to the driver so that he can operate the vehicle safely at night, to increase the safety of vehicle, and to convey information to other people on the road about the vehicle presence, position, size, direction of travel, the driver intended direction, and speed of travel. Besides this, the illuminating instrument on dashboard and inside the vehicle, the light of the roadway for the driver and increases the visibility of the vehicle, allowing other drivers and pedestrians to see vehicles presence. The different lighting equipment to warn drivers and indicate priority of movement in traffic, such as emergency vehicles usually carry. The blinker type of red light with purple glass fitted to an ambulance van used for conveying patients. The requirements of lightning system are: the lightning and light signaling devices shall be so installed that under normal conditions of use and notwithstanding any vibration which they may be subjected to. The illuminating lamps shall be so fitted that alignment can be easily set correct. Reference axis of all light signaling devices when fitted to vehicle shall be parallel to horizontal bearing plane of the vehicle. The height and alignment of lamps should be checked in absence of specific instruction with vehicle unladen and located on a flat horizontal surface. Lamps constituting a pair shall be installed on vehicle symmetrically in relation to longitudinal median plane. The lightning fixtures, housing, and sockets shall not be used as ground return for any other electric circuits. These are the requirements of an lightning system. Next point is types of lights. Modern vehicle uses different types of light for various purposes. The main lights are as follows. The first one is headlight or headlights. The function of headlights is to illuminate highway road sufficiently to permit safe night driving. Generally, these are provided with two beams, one with high intensity to give maximum illumination for night driving, and other gives deflection to ground and to side of the road to minimize glare and passing of cars on the road. Sometimes a third beam is used which is of low intensity for city driving. Next is parking light. In addition to headlights, low intensity parking lights are usually provided in the front of the car, either separate unit or as a part of headlamp, and are used while the car is parking. For parking the car during dark, parking lights are kept on to provide a signal for other moving objects, and third, and thus avoid the accidents. Third, direction lights or signal lights. Directional signal lights, known as directionals, blinkers, indicators, or flashers, are blinking lamps mounted near the left and right, eight front and rear corners of an vehicle. These are used to indicate the direction in which the vehicle is going to take a turn. The lights give signal to vehicle coming from front or rear. In addition, some special signal light are also used. These indicates or these include the blinker lights. These give red signal light to indicate when high beams of headlamps are burning, to indicate when parking brake is applied, to indicate that oil pressure is low, cooling water temperature is too high or too low, or the generator is not charging the battery. These are the blinker lights presented in the dashboard of an vehicle. Next are the backup lights. Backup lights turn on when driver shifts into reverse. This closes a switch linked to selector lever which connects the backup light to the battery. Blinker lights provide means of signaling when cars is stalled on highway or has pulled off to the side. The blinking is much more noticeable than steady light and provides warning to the approaching cars. Also, the stop lights are used to stop the vehicle or to show that the vehicle is in stopped position. Sixth is backup lights. Backup lights turn on when the driver shifts it into reverse gear. 7. Tail lights. Tail lights illuminate back of the car in the night so that other vehicle coming from behind are able to see the vehicle. Tail lights are kept on all the time when the car is running in night. Stop lights are also used at the rear of the car and become on when brakes applied as discussed earlier. And the last are the interior lights. To illuminate the interior of vehicle, various types of lights such as instrument panel light, various indicator lights, compartment lights, keyhole lights, map lights, radio dial lights, clock lights are also provided in cars. To understand the wiring of automobile, the vehicle are coded with the vehicle are coded with different colors of wires in the lighting system. This can be defined as cable color coding of wiring the lighting system. To carry the current to various electrical units of an automobile and for identification of cable, different color codes are used. There are the main 7 colors which we know, that are brown, yellow, white, green, blue, red and black. Their application and being as follows, and each color has their own identification in wiring of the light. The first color is the brown color. The color code is capital BR. Its the function is, or the color wire is used for connecting the battery circuit. The second is yellow color, given by Y, capital Y. It is used for generation circuit. Third is white, given by W, capital W, used for ignition circuit. Fourth is green or light green, given by G, and it is used for auxiliary circuit. Fifth is blue, that is given by BL, and the function is or it is used for headlamp circuit. And the last 6 red is used given by R, used for side lamp and tail lamp. And the last is black, denoted by B, used for earthing circuit. Next point is types of gauges. Basically, an automobile consists of number of gauges. The function of gauges is to indicate the amount or quantity of material present in an automobile. There are 3 types of gauges. First is an fuel indicator or a fuel gauge. The fuel gauge indicates the amount of fuel remaining in the fuel tank. There are 2 types of fuel gauges. The first one is bimetallic resistance type and the second one is cross coil type. The cross coil type of fuel gauge is nowadays used in recent automobile vehicle. The second is oil pressure gauge. The oil pressure gauge is the used for indicating the oil pressure inside the IC engine. These are of either mechanical or electrical type. The mechanical pressure gauge is in the form of bourdon pressure gauge on the dashboard. And the third is water temperature gauge. Water temperature gauge is used, or the function of water temperature gauge is to indicate the temperature of cooling water that drives all the time. It is an optional accessory provided on engine. It is very economical but important one. This is again of two types, the mechanical type and the electrical type. Next important electronic component and is windscreen wiper. Windscreen wiper or windshield wiper is a device that is used to remove the rain and debris from windscreen or windshield. That is windscreen wiper is a device used to remove the rain or water particle or dust particle on the front side of an vehicle or of the glass. This is helpful, and the windscreen wiper is helpful during wet atmosphere, rainy season, and snow. Almost all automobiles are equipped with wiper, which are usually a legal requirement. Most automobile use two synchronized type arms, while many commercial use only one or more pantograph arm. Construction and working. The modern car provided with effective high-speed wind wiper operate by electric current, that is with the help of battery or by vacuum operated unit. A wiper, as shown in figure, generally consists of an arm pivoting at one end with long rubber blade attached to other. The blade is swung back and forth over the glass, pushing water from its surface. The speed is normally adjustable with several continuous speed and often one or more intermittent settings. The windscreen wiper consists of a small motor, worm gear, and a worm wheel assembly and a flexible cable. It is fitted in bonnet and easily accessible whenever it is required. The motor provides drive through the reduction gear. It provides reciprocating action. This reciprocating action is converted into angular displacement of wiper. A helix form around the cable constitutes rack and wheel gearbox. The cable passes through two wheel boxes at wiper end of the unit. The worm arm spindle carried in bearing. Wiper blade driven by wheel rotating back and forth in wheel box due to pulling of cable rack backward and forward. Most automobiles use two synchronized radial type arm, while many commercial use one single or windscreen wiper. The last part of this session, automotive sensors and actuators or types of sensors. Automotive manufacturers are continuously increasing the use of electronic system to improve vehicle performance, safety of the vehicle, and passenger comfort. Sensors and actuators integrated with automotive control computer help optimize vehicle performance while improving reliability and durability. The various types of sensor are shown below. The first one is an inductive sensor, also called as inductive proximity sensor, is a type of electronic proximity sensor that is used to detect the position of metal objects without touching them. The sensing range of an inductive switch is dependent on the type of metal to be detected. Ferrous materials such as iron and steel allow for a longer sensing range, while non-ferrous materials such as aluminum, copper can reduce the sensing range by up to 60%. Second, Hall effect sensor. Hall effect sensors are often used for the purpose for detecting the position of moving objects. Hall sensors are contactless operational. Because of this, they do not wear out through contact, and hence these are maintenance free. These are unaffected by temperature fluctuation and vibrations. Third, light sensor. Light sensor. This device allows one or more lamps to illuminate at sunset and turn off from a trigger device for the SCR, providing short pulse frequency. Pulse duration is set. When light hits the photoresistor assumes very low resistance value, almost shorting and preventing circuit operation. When it is dark, the resistance value become high and thus enabling circuit operation. Hmm. Light circuit light sensor is used to increase or decrease the output of an light. Fourth is resistive sensors. Resistive sensors such as potentiometer have three terminal power input, ground terminal and variable voltage output. These mechanical devices have varied resistance and that can be changed through movable contact with its fixed resistors. Output from sensor varies depending on whether the movable contact is near the resistor supply and or ground end. Fifth is voltage generating sensors. Voltage generating sensors such as piezoelectrics generate electricity by pressure with the types of crystals like quartz. As the crystal flakes or vibrates, AC voltage is produced. Knox sensors utilize this technology by sending a signal to automobile onboard computer that engine knock is happening. Next is switch sensors. Switch sensors are composed of a set of contacts that open when close to a magnet. A reed switch is a common example of switch sensor and most commonly used as speed or position sensor. Next is temperature sensor. Temperature sensor, when two dissimilar metals are joined together, the thermocouple junction is formed. Among the two junctions used, one junction is kept at constant and known temperature where other temperature is measured. Example, 70% platinum and 30% rhodium alloy and known as B-type has a range of 1500 degree Celsius. The electric resistance of sensor decreases as the temperature increases. These are used in engine block, coolant circuit, air intake circuits. Next is pressure sensor. Pressure sensor it supplies the engine load information to engine control unit or engine control module. The engine control module uses this information to calculate the fuel delivery. In addition, some engine control will use map sensor forming sensor information to calculate spark timing. That is manifold absolute pressure sensor. Ninth one is oxygen sensor. Oxygen sensor produces a voltage signal based on the amount of oxygen in the exhaust of engine. This voltage signal is used by ECU, electronic control unit or electronic control module, to provide air fuel mixture information for fuel delivery and emission control. The 10th one is crankshaft position sensor. The crankshaft position sensor is used by the control module to calculate engine speed and cylinder position. The control module uses this information for fuel delivery and proper ignition system. And the last is throttle position sensor. The throttle position sensor TPS is variable resistor that changes value based on the throttle movement. The control module uses information from this sensor to adjust the delivery of fuel to compensate for throttle opening. Vehicle equipped with electronically shifted transmissions use information from throttle position sensor to control transmission shifting. This is it for today's session. This is the last session of chapter number 5. We have completed our chapter number 5, automobile electrical and electronic system. If you have any queries, you can contact me. Thank you. You can also search in YouTube or Google for various videos or information and related any type of electrical and electronic instruments, and for easy understanding or understanding in your own language, in Hindi or in Marathi. Thank you.